Hello everyone, in this video we will learn all about differentiation of trigonometric and exponential functions. Derivatives of trigonometric functions. The derivative of sine x is cosine x. The derivative of cosine x is negative sine x. The derivative of tangent x is secant squared x. Derivative of cotangent x is negative cosecant squared x. The derivative of secant x is secant x tangent x. The derivative of cosecant x is negative cosecant x cotangent x. Now take note of this. We have here cosine, cotangent, and cosecant. Take note their derivatives are negative. So it might help you remember the signs of trigonometric functions. If it's c, it's actually negative. So for example, if we're given the function sine 2x, what is the derivative of this? So take note, the derivative of sine is cosine. Copy the angle and get the derivative of that angle. Take note, the derivative of 2x is 2. So with that, our final answer would be 2 cosine 2x. Another example. We're here. Y is equal to tangent 5x cubed. Take note, the derivative of tangent is secant squared. So secant squared, copy the angle and get the derivative of that angle. So derivative of 5x cubed, multiply, so that would be 15. Then minus 1, that would be x squared. So take note, the rule in derivative is multiply and minus 1. So with this, our final answer would be 15x squared secant squared 5x cubed. Another example. If you're given secant x plus 3 cosecant x, get its derivative. So take note with this, derivative of secant. So that would be secant x tangent x plus, we have here a constant 3. Derivative of cosecant is negative cosecant x cotangent x. So final answer, multiply this with 3. So that would be negative 3 cosecant x cotangent x. Now, let's prove why the derivative of sine x is cosine x. So to do that, let's review some equations that will help us in proving. Now, given this general addition formula, sine a plus b is the same as sine a cosine b plus cosine a sine b. Another one is the special limits of 1 minus cosine x over x as x approaches 0 is 0. And the other one is the limit of sine x over x as x approaches 0 is equal to 1. Now take note, we had this in the previous lessons. So with that, again, we're given here the equation y is equal to sine x. Now the formula for derivatives, so take note of this. So all we have to do here is substitute. So the limit of sine, so that would be x plus delta x minus sine x over delta x as delta x approaches 0. So in here, let's apply the general addition formula. So we have here our a and this will be our b. So with that, that would become sine x cosine delta x plus cosine x sine delta x, then minus sine x over delta x. So let's simplify. So that would become sine x cosine delta x, then minus sine x plus cosine x sine delta x over delta x. So with this, sine x is common, so factor it out. So that would become sine x. So what's left is cosine delta x minus 1. And the other side, that would be cosine x sine delta x over delta x. So take note here, our target is to apply this one. So take note, we have here cosine delta x minus 1. So take note, this is 1 minus cosine x. So to do that, let's factor out the negative sign. So that would become negative. So this would become negative cosine delta x. So negative of negative, so that would be plus 1. So you might wonder why sine x is moved here, because sine x has nothing to do with the limit. So just write it outside. Then the same thing for cosine, so write it out. So cosine x, so limit of sine delta x over delta x as delta x approaches 0. So take note, the limit here is actually 0, but you still have negative here. So this would become negative sine x times 0 plus we have here cosine x. So the limit here making use of this is actually 1. So at this point, we can cancel this. So what's left is y prime is equal to cosine x. So again, the derivative of sine x is cosine x. So that's how it is derived. So we don't really have to discuss the rest of the proof for the rest of the trigonometric functions. So take note of that. So let's have more examples. So if we're given here sine 3x plus 1, so what is its derivative? So again, derivative of sine is cosine. So that would be cosine, copy the angle, get the derivative of the angle, which is 3. So final answer would be prime, y prime is equal to 3 cosine 3x plus 1. Another example. So we're given here f of x is equal to cosine squared is equal to x. So take note here, cosine is raised to 2. So rewriting that would become cosine x squared. So again here, the derivative of cosine is negative sine x. So that would be, so in this case, so since this is raised to 2, so we will make use of the chain rule. Get the derivative times the derivative of the base. So get the derivative of this, so that would be 2 cosine x, so 2 minus 1, so that would become 1, times derivative of cosine x is negative sine x. So simplifying, our final answer is negative times 2, so that's negative 2 cosine x sine x. Another example. So we have here 3 terms. So we have here x cubed plus sine x plus 4 cosine x. Get its derivative. So first, the derivative of x cubed is 3x squared. Derivative of sine x is cosine x plus 4. Again, derivative of cosine x is negative sine x. Simplifying this, so as is, so positive of negative, so minus 4 sine x. Another. This is y is equal to secant x squared. So again, this time, our angle is raised to 2. So how to get its derivative? So take note, the derivative of sine secant x is secant, copy the angle, x squared, tangent x squared, and the derivative of the angle, which is 2x. So final answer is 2x, secant x squared, tangent x squared. Okay, another. So we're given here y is equal to x squared sine x. So take note in here, we have here x squared times sine x. So we can make use of the product rule. So with the product rule, copy the first, multiply the derivative of the second, then copy the second and derivative of the first. So that would be x squared, derivative of sine x is cosine x, plus copy sine x, and derivative of x squared is 2x. So final answer is x squared cosine x plus 2x sine x. Okay, another. Now this time, we have here y is equal to tangent times sine 4x. So to do this, derivative of tangent is secant squared. So here we have here sine 4x. Then times, our derivative of sine is actually cosine. Then copy the angle, which is 4x, and the derivative of 4x is actually 4. So final answer is 4 cosine 4x secant squared sine 4x. Okay, another. Now this one is y is equal to sine x over x squared. So with this, we can make use of the quotient rule. Now with the quotient rule, copy the denominator times derivative of numerator minus copy numerator times derivative of denominator over denominator raised to 2. So that would be x squared, derivative of sine x is cosine x, minus copy sine x, derivative of x squared is 2x. So that would become, and denominator is x squared raised to 2. So at this point, so x here in the numerator is common, so factor it out. So what's left is x cosine x minus 2 sine x over x4. At this point, we can cancel x. So final answer is x cosine x minus 2 sine x over x cubed. Okay, another. Derivatives of exponential functions. Now, derivative of e to the power of u is e to the power of u times the derivative of u. So with that, copy the given and get the derivative of the exponent. So that's why if we're given e to the power of x, its derivative would be e to the power of x times the derivative of x, which is 1. So that's why it is simply e to the power of x. For example, if we're given f of x is equal to 3x e to the power of x, derivative to that would be 3e to the power of x. Another example, if we're given f of x is equal to e to the power of 2x, so with that, copy the given to get its derivative and derivative of the exponent, which is 2. So final answer is 2e to the power of 2x. Another, if we're given here e to the power of 3x squared plus 8x, to get its derivative, copy the given, and the derivative of the exponent is 6x plus 8. Final answer is 6x plus 8 times e to the power of 3x squared plus 8x. Now, let's prove how come the derivative of ex is ex. So, with that, take note of this special limits of e to the power of x minus 1 over x as x approaches 0 is 1. This is the third special function. Okay, we had this in the previous lessons as well. Okay, so with this, so again, the formula for derivatives is this one. So let's substitute. So that would be e to the power of x plus delta x minus e to the power of x over delta x. So at this point, e to the power of x is common, so factor it out. So we're left with e to the power of delta x minus 1 over delta x. So that would be the limit of e to the power of delta x minus 1 over delta x times e to the power of x. Now, take note, the value here is 1. So that would be y prime is 1 ex, or that would be simply ex. So again, that's the proof of the limit or the derivative of ex is ex. Okay, what is the derivative of 3 to the power of x? Now, with this, the derivative of a to the power of u is copy the given times the derivative of the exponent times the natural log of the base. So, again, e to the power of u, its derivative, copy the given times the derivative of the exponent times the natural log of the base, which is e. So, again, ln of e is just equal to 1, so that's why it is simply cancelled. So with this, our derivative here is 3x, the derivative of the exponent is 1, times the natural log of the base, which is 3. So final answer would be 3 to the power of x, natural log of 3. So another, if we're given y is equal to 7 to the power of 2x minus 3, to get its derivative, copy the given, times the derivative of the exponent, which is 2, times the natural log of the base, which is 7. Or we can rewrite it this way. Another, if we're given y is equal to 4x cubed. So again, to get its derivative, copy the given, times the derivative of the exponent, which is 3x squared, times the natural log of the base, which is 4. Or we can rewrite it as 3x to the power of 2 times 4x cubed, natural log of 4. So again, if we're given a to the power of x, its derivative is simply a to the power of x times the derivative of the exponent times the natural log of a. Okay, another. If we're given y is equal to e to the power of sine x. So with this, to get our derivative is e to the power of sine x, copy, then the derivative of the exponent, which is cosine x, times the natural log of e. So with this, since ln of e is 1, so our answer would be e sine x times cosine x. Okay, another. Y is equal to 4 to the power of tangent x. So to get its derivative, copy the given. The derivative of the exponent is secant squared x times the natural log of the base. Okay, another. So if we're given y is equal to x cubed times e to the power of 4x. So in here, we can make use of the product rule. So with the product rule, copy the first and get the derivative of the second. So derivative of the second is, copy the given, e to the power of 4x times derivative of the exponent is 4, then natural log of e, plus copy the second, and derivative of the first, which is 3x squared. So simplifying this one, so we have here 4 times x cubed is 4x cubed, e to the power 4x, plus e 4x times 3x squared. So take note in here, we have here a common, which is x squared and e to the power of 4x. So factor it out. So what's left here is 4x, and at the other side is 3. So this will be our final answer. Okay, another. So we're given here e to the power of x times sine x minus 3 e to the power of x cosine x. So with this one, this is product rule. So with this, copy the first, then derivative of the second. So derivative here is cosine x, plus copy the second, and derivative of ex is simply ex. Then minus 3 is constant, so just write it outside. Then again, copy the first, ex, then derivative of the second. So derivative of cosine is negative sine x, plus copy the second times derivative of the first, which is ex. So simplifying this one, we will get ex cosine x plus ex sine x plus, because it's negative of negative, so that would be plus 3 ex sine x. So negative times positive minus 3 ex cosine x. So combining like terms, so we have here ex cosine x minus 3 ex cosine x. So that's negative 2 ex cosine x. So combining this two, we will have 4 ex sine x. So take note, ex is common, so factor it out. So ex would become 4 sine x minus 2 cosine x. Higher order derivatives. Now, these are the notations for higher order derivatives. So for the first derivative, we have here y prime, f prime of x, and so on. For the second derivatives, we have here y double prime, or it could be f double prime of x, and so on. And the third derivatives could be y triple prime or f triple prime of x, and so on. So whatever method that we will use or whatever notations we will use, it's absolutely fine. Okay, let's have an example. Find the third derivative of y is equal to 4x cubed minus 5x squared plus 3x minus 7. So with this, to get our first derivative, so multiply minus 1, so 12x squared minus 10x plus 3. Now second derivative would be 2 times 12 is 24x, then 10. And the third derivative here would be 24. Okay, another. Y is equal to cosine 4x. To get the first derivative, so derivative of cosine is negative sine 4x, and the derivative of the angle, which is 4. Or that could be negative 4 sine 4x. Now, to get the second derivative, so that would be negative 4, and derivative of sine is cosine. Copy 4x, and derivative of 4x is 4. Or we can simplify it as negative 16 cosine 4x. Now, to get the third derivative, so negative 16, again, derivative of cosine is negative sine 4x, and derivative of 4x is 4. Or we can rewrite it as 16, because it's negative 16 times 4, that would be positive 64 sine 4x. Okay, another. Find the second derivative. So in here, we have here x squared cosine x. So we can make use of the product rule here. So copy the first, derivative of the second. So that's negative sine x, plus copy the second and derivative of the first, which is 2x. Or we can simplify it as negative x squared sine x plus cosine x 2x. So in here, to get the second derivative, so again, copy the first and derivative of the second, plus copy the second and derivative of negative x squared is negative 2x. So plus copy the first, which is cosine x, times derivative of the second, which is 2, plus copy the second and derivative of the first, which is negative sine x. So simplifying this one, we will get this. So combining like terms, so our final answer is negative x squared cosine x minus 4 sine x plus 2 cosine x. So that's our final answer. Okay, another. Okay, given y is equal to the square root of x, it's the same as y is equal to x to the power of 1/2. Now, to get the first derivative, so that would be 1/2 x. So 1/2 minus 1 is negative 1/2. Now, to get the second derivative, so negative 1/2 times 1/2 is negative 1/4. Negative 1/2 minus 1 is negative 3/2. To get the third derivative, so that would be negative times negative, so that's 3/8. So negative 3/2 minus 1 is negative 5/2. Or we can rewrite it as 3/8 x to the power of 5/2. Or rewriting this, we will have 3/8 square root of x to the power of 5. Or that could be x squared times square root of x. So rationalize it. So multiply the entire equation by square root of x. So our final answer would be 3 square root of x over 8x cubed. Okay. Another. Y is equal to 2x minus 3 to the power of 4. Now, to get the first derivative, so by the way, we will apply the chain rule here. So our first derivative here would be 4, 2x minus 3. So 3 derivative of the base is 2, or that would be 8. 2x minus 3 to the power of 3. To get the second derivative, so 8 times 3, that would be 24. So 3 minus 1 is 2. Derivative of the base is 2. Our final answer is 48. 2x minus 3 to the power of 2. Now at this point, to get the third derivative, so 48 times 2, so that would be 96. So 2 minus 1 is 1. Derivative of the base is 2. Our final answer is 192 times 2x minus 3. Okay, so that would be all.